Okay, good morning. So this is going to kind of be our new thing. We're going to go through chapter 9. I'll teach the notes in this way. So if you have a printer and you can print these pages, that'd be great. If you don't, you could always just take these on notebook paper. I do highly recommend that you take the notes just like we would in class, because I think that's going to increase your understanding and your ability to be able to work out the problems. So today we're going to start chapter 9. And we're going to write and use inverse and joint variation models. So I'm just going to do a couple of these warm-ups real quick, okay? Getting y by itself. This one you would obviously need to subtract the x, and so it would end up either 2 minus x or negative x plus 2. We will probably recognize that equation as being a linear equation, hopefully by now. Over here, if we want to get y by itself, we have to divide by x. Whoops. So we get y is equal to 8 divided by x. Here, we would just have to divide by 2. So y would be x squared divided by 2. So you can see these are all very different types of functions. And then here we would divide by 8. And so we would get y equals x divided by 8. Okay. Recall. So when it says recall, remember that we have discussed this before. So two variables show direct variation if y equals k times x, which with k being that constant. So two variables, x and y, are going to show inverse variation if y equals k divided by x, but k cannot be 0. Because if it was 0, it would wipe it all out, right, and make everything 0. So the non-zero constant k is called the constant of variation. And y is said to vary inversely with x. So you're going to hear directly, inversely, and jointly. So some of this we've kind of discussed before, but we're going to take it a little more in depth at the beginning of this chapter. So these are going to ask you, do x and y show direct, inverse, or neither for variation? So if you notice here, it says solve for y. And then you're going to want to look at, does it look like it's this, y equals some constant times x, that's going to be direct, or is it some constants divided by x, and that's going to be inversely. So to get y by itself here, we would divide by x. So we get y equals 4.8 divided by x. And so that looks just like this one right here. So this is inverse variation. Okay, for this one, we're going to multiply both sides by 1.5 to get y by itself. So we're going to get 1.5x equals y. This one would be direct. Now, I know the y is over on the right side, but obviously you could flip that around too. And then for this one, you're going to add 5 to both sides. So we get y equals 3.5x plus 5. So the beginning of this looks direct. Like if I covered up that plus 5, we would be like, okay, that's direct. But when you add something else to it or subtract something else from it, this one is neither. So again, this is the format for direct variation. This is the format for inverse variation. Make sure that you have those two things in your head. Okay, so on these, they tell you which way they vary. So x and y vary inversely. So in my head, I am like, okay, y is k divided by x. Now it says y is 6 when x is 1.5. They're just giving me one example of this inverse variation. So it says write an equation, and we used to mess these up kind of first semester. So I have to find k by using this y and x that they provide, but then I have to rewrite the equation, this exact equation with k solved for. So basically I'm going to take the 6, place that in for y, take the 1.5, place that in for x. I'm going to multiply both sides by 1.5 so that we get k to be 9. Now this is not my answer. That is not an equation. If you notice, this says write an equation. This is just telling you what your constant is. So I'd have to go back to my original equation. This is my equation that relates x and y together. Now that I have this inverse variation equation, I can find any values that they ask me to. So if you go to part B, it says find y when x is 4/3. So they're trying to obviously be tricky here. A fraction within a fraction. Now a ton of your calculators would do this for you, but this is the same as 9 divided by 4/3. So that's keep, flip, change, and so we get 27/4. You could leave it like that, or obviously you could divide it out. Whoops. And tell me 6.75. So on all these, I'm pretty sure in your homework, you're going to have to find the equation first and then give the value that they ask you to find. So just be careful about that. Okay, page 2. It says the volume of gas in a container, so volume of gas in a container varies inversely, so that's going to be important, with the amount of pressure. So the volume of gas in a container varies inversely with the amount of pressure. So right there, that's telling me the volume varies inversely with the pressure. I can go ahead and write that equation down. A gas has a volume of 75 cubic inches at a pressure of 25 pounds per square inches. Write a model relating volume and pressure. So we need to find K. Anytime you see this, write a model or write an equation, we want to know we're going to write this equation, but with K plugged in. So I can find K because it tells me when the volume is 75 that the pressure is 25. It gives me that information. So then I would just multiply both sides by 25. I would get K to be 1875. So that goes here. And there's my model. So they could use the words write a model or write an equation. Okay, this one says, does this data show inverse variation? If so, find a model. So in order for it to be inverse, okay, what does that tell me about K? Well, K would always have to be y and x multiplied together. So if I'm checking for inverse, I'm going to multiply y and x and just see if they're the same every time. So K would be 18 here. What's 4 times 4.5? That's going to be 18. 6 times 3 is 18. 8 times 2.25 is 18, and 10 times 1.8 is 18. So yes, it is showing inverse variation, and if it says find a model, that's just another word for equation. I know what K is, so my model is y equals 18 over x, and I'm done. Okay, just a little hint. If you were given a table and they wanted to know if it was varying directly. So if you think about the direct variation equation, okay, this is direct, so how would you find K? You would have to divide both sides by x. So if you were asked if a table was showing direct variation, you're going to want to do y divided by x, y divided by x, y divided by x, and see if you're getting the same number. Okay, last little part here, and then I promise we'll be finished. Joint variation occurs when a quantity varies directly as the product of two or more other quantities. So this is very similar to just a direct variation. It just has more quantities involved. So instead of it being y equals k times x, it might be z equals k times x times y. Now obviously we have that stipulation that k cannot be 0 because it would wipe all that out. So write an equation for the given relationships. So y varies inversely with x cubed. So y varies inversely with x cubed. And that would be that equation. Y varies directly with x squared and inversely with z. So y varies directly with x squared, but inversely with z. So that one would look like that. This one, z varies jointly. So that's like a big extended direct variation with x squared and y. And you don't have to put the dots in between. I'm just doing that. Okay, and then the last one, y varies inversely with x and z. So x and z. So that would be that one. All right, I hope this helps. Please let me know if you have questions, and I will post your homework assignment. Just remember, homework's always due at 10 a.m. the next day.